So here's our experience server, which I kind of copied some boilerplate. So we start the server, and I kind of made it more generic where there's only one process event. So anytime you want to send a message, you specify the slug and then the event name and a payload, and then we just send that asynchronously to this genserver's PID. So it says process event, passing in the event name and the payload. So you won't end up with a whole bunch of different kinds of functions here. You'll just have one function to receive any kind of event. It's just called process event. And then over here, where you actually process it would be the handle cast of the process event. So here we destructure the event name and payload, and then we delegate it to the game, which is the module, to load up that previous state, game state, pass it the event name and the payload, and you get back a new game state and then a command. So this is kind of following the Elm architecture. So you can have a previous state, you take some input, and you get back the new state and a command. And so here's the state, the new state being set into everything else that the genserver is keeping track of. One of them is game, which is this game state. And then we process the command. This allows us to fire something after a certain amount of time. Let's say 2 people opted in, and then you check, oh, we have a minimum of 2 players, so now we can send ourselves a new message that says start the game or something like that. So we can take a look at the game state here. Okay, this is game state, which is nothing more than this is kind of like a cheat to create enums. So you can just have 2 of these enums so that when we use the VS Code, it will autocomplete states. So the actual meat of it is in game. So here is the game module, and it is a struct. It has a participants map of people in the game. It has some kind of configuration, which is some kind of struct to be defined. And then it has one of the game states. So remember, when we looked at game state, there's 2 game states. You're either the game is running or it's not running. So maybe that could be playing, not playing, because your room is up. So maybe we can say that. We can say, or maybe game in progress, and maybe no game in progress. So if I change these things, this is what I wanted to achieve. So I do not have a state called not running anymore. So I need to say dot, and it can autocomplete. So the default is there's no game in progress. And now, so whenever you create a new game, you're going to get these defaults. And let's see. So we have this process event function, which this has several function heads. So one of them says a new person entered. So you take an event name and then some payload. So if a person entered, we want the ID of the person. So person entered. So then we basically add a new participant ID to a map, and then we stick that map into the participants. So we stick a new ID into here. And participant, we have another struct for that, which contains the ID, some health. You're going to start off at 100%, and then your own state, which can start off as not playing. And the way I did this, the state in this one is that I just don't expose, like we should never have to type this symbol outside of here. So I'm using functions to modify it. So if you want to say, you say stop playing or start playing. That way, if we need to modify any of these symbols, we just modify it inside this file so we don't expose them out. So I kind of manage the enums in a slightly different way in this one. So right now you can only be playing or not playing, and your health can be some integer and you have an ID. That's all data that's attached to a participant. So in this game experience, or yeah, I might need to consolidate these names because I'm using both experience and game and kind of these things. So the experience is kind of like the server that wraps the game. And the server might have more variables other than the game, like we might have timers and things like that. Game is kind of the pure functional side of how you move your game forward through its states. So we want to have an enriched way of coming up with a configuration, but this just loads a configuration. So right now this configuration is an empty map. We can take a look at how this is defined. So right now this configuration is very simple. You can only keep track of one thing, something called minplayers with it, which is an integer, and it starts off as 0. So when we load this, we get minplayers is 0. You can override this. So if somebody passes in the game and a new configuration, we'll just stick the new configuration into the game. And this is what I was working on. This is not quite finished yet, but let's go to go through the process events. So we have somebody entered, right? And then somebody opts in. So if somebody clicks on a thing, let's suppose they can send us a message that says this person is opting in to play a game. So opt-in always means I want to play. So anytime you enter a room, there can be one game going on, and you either want to play or you're just hanging around watching, in which case you never opt in. You don't have to play. But if you opt in, what we're going to do is we're going to modify the participant. So we find the participant by your ID that you passed in, and then we change its state. So actually, we shouldn't do this, right? We should use those functions, which should be participant dot. We should create one ready, or maybe just opt in. Oh, which we have one, looks like. So pass in the participant. There we go. So my objective is to not have to know what this thing is. That symbol at the end. Okay. So if we look at how this is implemented, opt-in just sets the state to ready to play, which is what we want. So we're modifying the participant from within a map, right? So game has a map of participants. We're modifying the participant within that map and sticking it back into the game, getting a new game. So we've opted in. And now every time somebody opts in, we're going to check our configuration. So we can check the game configuration, look at minplayers and say, and then we count the number of participants that are ready to play. So I wrote a function that maps over the game participants and counts up the number of people who are ready to play, which is down here, right? We count participants that are opted in. And if the number of participants we have that are ready to play is now greater than your minplayers, this criteria is met. So now we can send back the game a tuple, which is the game, the current state, and also a command. Now, right now I'm returning this symbol, which I think is fragile because any mistyping, like nothing's going to type check this. So we can also create like some kind of, we can use that trick where I showed you it kind of creates functions out of these things. But right now it's just a symbol. So let's just roll with this. So who listens to this thing, right? So if we come back to the experience server, when we process an event, if we do get a command, so we're going to destructure this, right? So every time we process the event, we get a new command, new game, and a command. We go process that command. The command can be nil, by the way. So we're going to look at this process command function head, which is right here. So if minplayers is met, now we send ourselves, the genserver, a message after 1 second, and we say, okay, go start the game. And then we'll receive our own message, which is in handle info start game. So then we can say game, start game, passing in the previous game, and we get a new game, put that back in the state. So let's take a look at start game. So start game goes through all the participants and that are opted in. So only those people who said they wanted to play, we're going to change their state to start playing. Otherwise, their state remains the same. We stick that back into the participants map. And at the same time, so we get a game out of this. And I think we're going to also want to do game.startGame around the game, which returns another new game. And that will call this function, start game. Oh, wait. I'm confused. I just called myself.
Yeah, you can call it. So you can do it a recursion,
right? That's not what I meant to do. I meant to set the game state. Okay, yes. So I want to do game state. I want to change this thing. So I'm going to return a new game, and the game state becomes game state dot game in progress. That's what I wanted to do, which I can do in just one go here. Game state. So if I save this way, what's it saying? Game is unused. Okay, I don't need to assign this to a variable. So if I run my test again, what I expect is that the game state before the default was not running will now say that it is running. And it is. So the game is in progress now. So if we were to do this in real time, it would be after 1 second, boom. So, and then we could do things like emit a message to our channel of this new state, and then for every person that wasn't playing, like they can start teleporting and things like that. So we're just kind of building some simple Lego blocks on top of this. Then I was coming at it from a different direction, which is what are the things that we can pull in to make Squid Game? So if I close these files, kind of looking at serialization of Squid Game. So here I have a squidgame.json file with a first stab at what constructs we would need. So first, let's say when you go to a URL and you pop into the place, you say, I want to enter this space. Where do you appear? So here's a construct that says that you start here. So every construct has at least a type. And so this is the library of certain types that we'll have. And this type of thing is called a spawn box, which means that this is an area that is this wide, this long, and will randomly pick a spot within this box that you will appear. So it has a position, which is the center of the box, and I'm moving this high up in the air because we're going to have some other geometry, which maybe I can create in Blender or something. I haven't pulled it in yet, but it's a spot on the balcony, so it's like 15 meters up in the air. It's high up. I'm not sure if we want to do scale or maybe dimensions instead, because I'm not scaling. I'm not making it bigger. It's just length and width. So maybe this is better, or maybe just length and width. So maybe it's length, and maybe it's a plane. It's a spawn plane, because you don't really need to know the height of it. So then you have length, which is maybe 3 meters, and then maybe a width and this can be 3 meters. And that just allows me to pick a random spot in there. So when you're spawning into it, you don't end up like always, if 2 people spawn in, you won't be on top of each other. So hopefully the randomness can spread them out a little bit. So this is one aspect, that the bare minimum of what we need, right? We're spawning into an area, and maybe initial, maybe it has a special meaning. Like anytime you have multiple spawn planes, initial is the first one you go to. Okay, and then we can have a construct that is the opt-in sign. And this will be similar to when Bobby and I were playing the VR game Arizona Sunshine. There's a sign, so you spawn in, but the game's not like running immediately. There's a sign, and it has 3 pieces of text. And so maybe the first text tells you what's going on. So it has some introductory text, and it says, okay, point and click here when you're ready to play the next game of red light, green light. And then when you actually do shoot it, just for you, it says stand by waiting for other players and the next game to start. So other players don't see that, right? Because they haven't opted in yet. And then third, when the game is actually starting, maybe we change the language again, which will be fast. Maybe there's only like 1 second, or maybe we can make it like a countdown. And then here's where that kind of minplayers is. So I don't know if it should be in this thing, but it's kind of tied together. It's kind of related, is that we're using this device to say, I want to opt in and play. And we're using this device to say we have enough players start the game. So I thought that min players would be a good parameter for this opt-in sign. And so if we set the min player to 1 here, then you can start playing Squid Game by yourself. You don't need any other players. Versus if you set it to like 10 players, the game won't start until you get at least 10 players going in. So setting it low means it's a good way to be able to try out the game. And then the debounce would be like, let's say if you have told people, let's say on social media, hey, come to this room and we can play together. But if you meet your min players right away, like you go, let's say min players was 2, first person opts in, second person opts in, third person is like having technical difficulty, it takes them like 5 seconds longer, then the game's already started and they're gonna have to wait for the game to end before they can join in. So the debounce time in seconds would be like first person joins in. When he opts in, you kind of like give 5 seconds before you immediately start the game. So the next person clicks the button, you get another 5 seconds. So if people keep joining in, you can keep extending it for another 5 seconds before it actually starts the game. At least that was an idea anyway. So here we can have another spawn plane. And this is the location for the actual game start. So we can call this game start. Maybe it has special meaning. And this one's on the ground. So the position is 0, 0, 0. You're on the floor. And let's just say this is length. And width. Something like that. So again, it's some point behind the starting point. And you don't get to teleport in here unless you've opted in. And so this is kind of related to the other one, right? But this one, these are gizmos or constructs that you can pull in from dropdowns, and then you have an editor where you can kind of have a form where you're typing in values for these things, or you can drag them around. So that's where the game will start. And then this is kind of a tricky one. Like red light, green light is like a very specific kind of state machine, right? It goes between red light and green light, and certain things happen on red light, certain things happen on green light. So I thought, what if we just made a kind of widget or construct that it just cycles through states? So it's called, the type of this thing is called a state loop. And this is what gives us the quality of red light, green light. And it will change the state between the red and green light. And so you give it a list of states. So maybe in between here, you can even say like a yellow light that you're using that to control some other things, but how this thing works, it'll just cycle through all of these states, starting with the first one. So we start on green light, we go to red light, we go from red light to green light, and then it has some initial delay. So however many states you have here, you have however many durations. So durations in seconds. So maybe you hold green light for 6 seconds, then you go red light to 4 seconds. But then that's kind of not fun if the time is always the same. So I thought maybe it can have some random gradual decay. So you keep kind of reducing the time until it gets faster and faster. Very fast red light, very fast green light within a certain minimum. But if you don't want that, you can just set that to false. So it's not a very flexible module. It's very opinionated. It's like I can't think of any other game that would use this except for maybe turn-based games where maybe it's like chess or something. Chess always goes from one player to another player and back and forth. But it's not like Mahjong, because Mahjong goes from one player to another player to another player, but not always. You can actually steal the turn from another player. So this would not be a good thing for something like Mahjong, because you need a lot more conditions. Whereas this thing, it unconditionally flips between the two, but we do have to have a mechanism for stopping it. For example, if everyone's dead, there's no point to keep going through the state loop anymore. And if nobody's playing the game, there's no reason to start the state loop. So we need to solve that additionally. So this is something that's there when it's on, but maybe we have a way of turning it off. Or maybe it's just a mechanism that it automatically knows to turn itself off if everyone's dead. And then if everyone's dead, then we can have something on the game state that says game not playing. And then when people opt in and they go game playing, then it knows to turn the state loop on. So maybe just the nature of how it's designed, it's always coupled with game state. Then we don't actually have to type out when I want you to start, when I want you to stop. It knows I'm going to start working all the time whenever you're playing, and I'm always going to like stop the red light, green light cycling if everyone's dead or everybody won, for example.
So do you anticipate more than one state loops in a game?
Depending on the game, we would just pull in some kind of different construct. So there might be more complicated constructs. I'm saying this might be an easy construct to pull in, but you might do something else for other games, like like maybe not have a state machine, but just handle message processing. And then how do you handle like what happens in those states? So I wanted to keep this simple, where when these states happen, we'll just have the server announce to the clients state is green light or state is red light. And then on the front end, we can process that message and do something on the front end, which is, let's say the message is green light, then we'll animate the head of that doll, right, to turn 180 degrees, and we can play a sound like zzz, like that, and we can deactivate some other construct, which is called death by motion. Or on the red light, we animate the head going the other direction, we play a sound, and then we activate death by motion. And here is the construct for a motion sensor, which is named death by motion. And what this thing does is it's a construct that will kill you if you move. So if you move around a lot, it's just going to set your health to 0, or maybe skip that thing. It'll just like respawn you up in the balcony and set your state to not playing. but you have a way of turning it on and off. So it responds to this activate. So there was two ways of doing this. One is inside the params, we could say, listen for message like on green light, do this thing, on red light, do this other thing. Or we have this kind of like signal to action, because these don't live anywhere. When you animate something, like maybe we could have this animate in the head. Okay, that makes sense. So playing a sound, yeah, maybe that belongs in the head. So maybe we don't need this signal to action. Maybe what we need is the head geometry, and then we nest this thing in there as some kind of listener. So maybe that might be a better design, more consistent. But there might be certain things that don't have an object that you can put it in. For example, if you're spawning a new object, you don't have an object to put that into, unless you maybe force them to grab a kind of construct that is a thing spawner, then maybe you put the message inside there. And that's what I have so far in terms of defining what the game is. Can you guys think of anything else?
So like if you load this JSON, right, like into the game, what do they, are these little things, are these type things, are they entities? Like I thought we talked about.
They are maybe bigger than entities. They are just
bigger than entities.
They're just
okay.
For example, this is not something that you would visually see, but it is it's like a piece of logic, right?
Yeah. Okay. Bobby said there's should be a timer thing or something. Timer.
Mm-hmm.
That indicates the length of the game.
Oh, like a clock? Right,
Yeah.
right. Let's see. Yeah, where should we put that?
I think timer by itself could be a standalone construct, a game timer.
Okay.
Sort of have a clock that can count down, like a timer, not a clock. And these are different things. Or a stopwatch, like what are you?
Yeah, Holman, I was just thinking in the context of the game, because I remember the Squid Game, like it seemed like they're all like some random timer.
Yeah.
And then so yeah, how I was just thinking, yeah, you would need something like that to like make the green light, then red light, then green light, red light, randomly.
Right. By the way, let me show you what someone built in Babylon.js. Somebody created this browser game. Let's see how it goes. I don't think it's multiplayer though, so you got 20 seconds. I didn't move. Very sensitive. Okay.
That looks pretty fun.
That's pretty cool.
You got a lot of money.
Yeah. So it's just not multiplayer. I don't think. Like if you guys open this up, you don't see me, right? I don't think so. It's also not VR. But it's proof that you can do it with Babylon.js. So game countdown, and then maybe name the duration of the game. Something like that. So maybe this is just automatically tied with the game. When the game starts, we'll have like the gen server send itself messages and then give a message to the clients that it's like going 19, 20, 21. And when it reaches 0, no matter where you are, it'll stop the game and teleport you back up. Yeah, you kind of don't want to teleport them right away, right? Because you want to see yourself get shot. So we can maybe address that. Okay, so we have this JSON. What I was thinking of is this same JSON declaration is parsed 2 ways. One way for the backend, where we're running Elixir. One way for the front end, where we're running Babylon.js. So with one specification, we have to parse it to see what's applicable to the backend and what's applicable to the front end. So let's work on the backend first. So let's start with our test. So we have the experience server test. And right now, I'm manually inserting this thing. But maybe we could do something like parse the squid JSON into an experience config, then put it in here, and that would allow us to get this value from those constructs. So I want to load a file. So how do I load this file? Look up Elixir read file. File open, file read. Is hello the name of the file?
Yeah, hello. World is the content. Okay, get some water.
Okay, how do I... So if I'm running from here, what is my path? squidgamejson. I think I need to go up a directory into support. Okay, I want to see what my current directory is. Okay, Elixir print current working directory. File current working directory. Let's see what that is. So IO inspect file current working directory. App source. Okay. App source. So then we want to go into test support. Actually, let me do this. Inspect. How about ls? ls. cd. ls a path. Okay. File ls. What's in my current directory? Okay. Whoa. Readme test. Okay. So we're gonna go here. Test support fixtures.
Mr. S.
Sorry?
Mr. S for test.
Oh.
Yeah.
Okay, squid game. Okay, so let's read that file. Read file from fixtures / squidgame.json. And let's see what that is. Pipe that to IO inspect. Okay. We get a tuple. So file read with a bang probably just doesn't have the OK in front of it, right? Cool. Okay, so we got a string, and then we want to pipe that into JSON.decode with a bang. Then we're going to have game spec is that, and we'll pipe this to IO inspect. Very cool. So we've got everything we typed in JSON text converted into Elixir structs. So we want to be able to parse and load. So we want to have something like experience server and parse game spec slug. I guess that's it, right? You just load it in there. Game spec. Okay. This isn't defined, right? So let's go to experience server. How come this isn't complaining? Yeah, parse game spec is undefined or private. Okay, parse game spec. Parse game spec. Let's have the slug come first. We'll have the spec. We don't need to decode it. We already decoded it. We go past. Get tuple slug parse spec with the spec. So we'll come down here and add parse spec. Parse spec with the spec. Oh, the other thing is that I pushed the spec into the game struct. So the game has this experience config. So this actually lives on the game, not on the server. So if you look at the state of the server, when we enter our OK method, our init method, it just has a slug and a game. So the experience is not on the server. It's pushed into the game so that we can make decisions in a pure functional way. So if anybody's going to parse it, it should be the game. So we have load get config, which just takes the config that's already there. But we need a way to maybe parse a spec. We take a game, and we take a spec, and I think what we want to do is we just want to pull out this optinsign. This is the only thing we can handle right now, and we're looking for minplayers in the params. So is there a way we can pattern match on that? So we know that this contains a map, right? Let's actually take a look. This is going to be a map of constructs. And this will be this. Yeah, this part can't pattern match because it's a list. So we have to do constructs. And in fact, let's write a test around the game construct. Let's see. We have tests. VXR spaces test. Okay, let's make one for game test. Copy this boilerplate. Game test XS. And I'll just say that this is game test and describe a game and just wipe out everything out. And so let's bring in XR spaces game, the XR game. Test parse a spec. Game equals game dot. I guess it's just this. got some defaults on it. So we want to be able to do load that file again. So where's our experience server test? Let's do this thing again. Game test. We got a game spec, and now we want to do game dot parse spec. Give it the game, give it the game spec, get a new game, and then we can IO inspect the new game. Constructs attempted. Got some open files here. Let me close some things here. So we're gonna handle parse spec, game process event. Okay, let's just comment this out for a second. Save this, and we'll do this later as well. I'm gonna program this from the game test itself. So here we send it to parse spec. Let's run this again. Okay, the one failure. We tried to send parse spec in with constructs. Oh, okay. So yeah, they're not symbols. Okay, we can fix that. So we come over here. This is constructs, like that. Okay, so it didn't break, but we want to assert that. So we want to find within this list enum.find and look through the enumerable, which is the constructs, and we want to pass it a function for the construct. Default is nil, I guess. And the construct must have a name equal to what was it called? Optin welcome sign. No, it's got to be a type. Optinsign. So hopefully you don't pull in two of these things. Yeah, we'll just take the first one. So optinsign. So it's the type called optinsign, which means that this is the optinsign construct. And then I guess we can check its condition. So case optinsign 2. So if it's nil, just return the game. If it's sign, then sign params, and then minplayers. Minplayers should equal that. And we want to, what does it say? Minplayers is unused, yeah. So I want to stick that into the game. So we turn a new game, copying game, where the config is equal to experience config with minplayers equal to minplayers. So that's going to parse the spec. So new game before the config was this. So if I run this again, I would expect minplayers here to be non-zero. And it works. So we got minplayers as 1. So we're parsing the game for the server. So if we were to load this JSON file from like the database or something, we could parse it in the back. People could opt in, and as soon as one person joins, after 1 second, the game starts. And we're at 8 o'clock. I might be talking to myself. Let me stop recording.